On August 12, 2021, at 1832 UTC, a magnitude 7.5 earthquake struck one of the most remote places on Earth. Seismologists looked at the numbers, saw a depth of 47 kilometers, decided at W as too deep to efficiently generate a tsunami, and moved on. 3 minutes later, a second earthquake hit, magnitude 8.1. Then, buried inside that same sequence, invisible in the initial data, a third event released roughly 70% of the total E. Nerge of the entire sequence, a slow, shallow rupture at just 15 kilometers depth that the world's seismic networks didn't fully identify until after the tsunami it generated was already crossing 3.0 through today. Because on August 12, 2026, exactly 5 years to the day after that sequence began, USGS seismometers picked up another earthquake in that exact same zone, magnitude 6.0, small by comparison, but it comes from a PL ACE that has already proven it can hide its most dangerous earthquake inside a sequence that looks, on the surface, like something far less serious. Let's get into it. Start with where this is happening, because the location explains everything that follows. The South Sandwich Islands sit roughly 2,300 kilometers east of the southern tip of South America, deep in the South Atlantic Ocean, near the edge of Antarctica. This is one of the most remote places on the planet. No permanent human pop. Eulation. No towns. No roads. Just a chain of jagged volcanic peaks jutting out of a freezing, storm-battered ocean, and more than 1 million penguins, which are the only regular inhabitants. The islands are the visible tips of a volcanic arc, a line of underwater and above-water volcanoes formed directly by one tectonic plate sliding beneath another. The machinery driving all of it sits in one of the most intense subduction zones in the South Atlantic, and that machinery never rests. Here's what's actually happening beneath that ocean floor. The South American plate is moving westward and diving beneath the South Sandwich microplate at a rate of roughly 65 to 78 millimeters per year. That number sounds small? It isn't. At that convergence rate, for the course of a single human lifetime, more than 4 meters of solid oceanic crust silently disappears into the mantle below. As the slab descends, it bends and fractures under enormous pressure, carrying water and minerals down into the heat of the Earth's interior and triggering melting in the rock above it. Some of that melt feeds the volcanic arc at the surface. Some of it builds pressure directly in the subduction zone. The slab dips at an angle of 45 to 55 degrees and extends at least 175 kilometers into the Earth before it fully melts into the mantle. That's the engine. It runs continuously, whether or not anyone is watching it. And on August 12, 2026, one small piece of that engine released energy at a depth of 10 kilometers with a magnitude of 6.0. To put that number in physical terms, magnitude is logarithmic, and each whole step on the scale represents roughly 31 times more energy released than the step below it. A magnitude 6.0 releases about 31 times more energy than a magnitude 5.0, and roughly 1,000 times more than a magnitude 4.0. The energy in this earthquake is comparable to detonating around 15,000 tons of TNT in a single moment. It struck at just 10 kilometers depth, which is shallow by seismological standards, meaning the energy radiated upward toward the ocean floor with relatively little of the distance dampening that deeper earthquakes experience. USGS issue. DA green pager alert for this event, meaning a low likelihood of casualties or significant damage. That assessment is almost certainly correct, because there is no population within reach of this earthquake's shaking. But a green alert tells you about immediate human impact. It doesn't tell you what this region is, or what it has already shown it's capable of. The South Sandwich Trench, where the South American plate dives beneath the Sandwich microplate, is one of the deepest features in the South Atlantic. It stretches for approximately 700 kilometers in a curved, bow-shaped scar across the ocean floor, marking the boundary where one plate vanishes beneath another. This trench has produced some of the largest earthquakes ever recorded in the entire Atlantic basin. The largest confirmed earthquake in the Atlantic Ocean's instrumental record came from this exact zone, a magnitude 8. One in August 2021, tied in size with a 1929 earthquake from the same region. And buried inside that 2021 event was a hidden earthquake that scientists are still studying because it revealed something genuinely uncomfortable about how well we actually understand seismic hazard in remote subduction zones. Let's slow down and walk through exactly what happened in 2021, because it's the reason this week's small earthquake deserves your attention. The first shock, magnitude 7.5, hit at 47 kilometers depth. That depth mattered to the people watching it happen in real time, because 47 kilometers is generally considered too deep to efficiently displace the ocean floor and generate a dangerous tsunami. Initial alerts treated it as a relatively low-risk event, and given the information available at that moment, that was a reasonable read. Then, 3 minutes later, the second earthquake hit. Magnitude 8.1, tied as the largest earthquake ever recorded in the South Atlantic. It ruptured the shallow portion of the subduction zone in an event that lasted an unusually long 260 seconds from start to finish. In the 24 hours that followed, 61 aftershocks of magnitude 4.5 or larger were detected, including 3 that individually exceeded magnitude 6. But it was the tsunami that made scientists pause. It crossed 3 oceans. It was recorded at coastal gauge stations across the South Atlantic, the South Indian Ocean, and beyond. And here's the E part that should stop you. The initial 7.5 had partially masked the seismic signature of the 8.1 that followed it, which meant the first tsunami warnings were issued based on incomplete information. USGS didn't confirm the 8.1 magnitude until the following day. That alone would be a notable story. It isn't the most unsettling part. A study published in 2022 by the American Geophysical Union revealed that the true source of the global tsunami wasn't the 8.1 at all. It was a third separate earthquake hidden within the sequence, a magnitude 8.2 event that struck at only 15 kilometers depth, shallow enough to drive serious ocean displacement, and is low enough in its energy release that it was essentially invisible in the initial seismic data. This sub-event contributed roughly 70% of the total energy released across the entire sequence, and it only became visible to researchers after careful post-event analysis by teams at Caltech and other institutions. Read that again. The single most dangerous earthquake in the entire sequence was nearly undetected, until after the tsunami it generated was already moving across the ocean. That 2021 sequence happened on the exact same subduction zone as the August 2026 magnitude 6.0. The coordinates aren't identical. The 2021 events centered around 57 to 58 degrees south latitude, while the 2026 event centered around 60.2 degrees south, a bit further along the same arc. But the mechanism is identical. Same plate, same trench, same process of sea, rustal rock fracturing as one plate grinds beneath another at rates up to 78 millimeters a year. What the 2021 sequence demonstrated is that this subduction zone is capable of producing extremely complex multi-event ruptures that get misclassified in real time, generating tsunami hazard that initial assessments underestimate. Researchers who published on the 2021 events noted explicitly that this convergence zone, roughly 1,000 kilometers long, with a convergence rate of 69 to 78 millimeters per year, is potentially capable of producing earthquakes reaching magnitude 9.0. That threshold has never been triggered, and nobody credible is predicting one right now. But the architecture that would allow it exists, and it's active. The August 2026 magnitude 6.0 is a small event on a fault system that has already demonstrated it can produce something vastly larger and can hide the most dangerous part of that larger event from the people watching it happen. Now go one level deeper, because this region isn't just seismically remarkable, it's one of the most volcanically active remote arcs on the planet. The South Sandwich Islands are the surface expression of the same subduction system driving these earthquakes. At least 6 individual VO Elcanoes in the chain have been active within recorded history. Since 1819, at least 13 historically documented eruptions have occurred across the island group, meaning a volcanic eruption has happened somewhere in this chain roughly once every 15 years on average across 2 central Reyes. The most frequently active of the South Sandwich volcanoes is Zavodovsky Island at the northern end of the chain. When the Russian explorer Bellingshausen first arrived there in 1819, the volcano was already erupting. Most subsequent visits have reported it smoking. Its most recent confirmed eruption was in 2016, when the British Antarctic Survey documented ash and steam emissions, with satellite images showing up to half the island coated in fresh ash. Nearby Bristol Island also erupted that same year, triggering a maritime navigation warning for the entire area. Further south along the chain on Saunders Island stands Mount Michael, an 843-meter stratovolcano and one of only a handful of volcanoes anywhere on Earth confirmed to maintain a persistent lava lake inside its summit crater. Not occasionally, persistently. There is, right now, a lake of molten rock sitting inside the top of this mountain in the South Atlantic, kept liquid by continuous heat rising from the subduction zone below. Mount Michael has been in a state of ongoing eruption since at least 20 kilometers, 14 with observations continuing through 2025. The island group also includes Montague Island, home to one of the largest volcanoes in the South Atlantic, with confirmed eruptions in the 20th century. None of these are ancient, dormant systems. They're active, connected to an active subduction zone, and fed by the exact same plate dynamics that produced the August 12th earthquake. What makes the South Sandwich Islands so scientifically important is precisely how isolated they are. There are no permanent seismic monitoring stations on the islands themselves. No GNSS receivers on the island, flanks tracking ground deformation in real time. Satellite data is limited by cloud cover, storm systems, and the difficult viewing angles at high southern latitudes. Almost everything scientists know about the deep seismic structure of this subduction zone comes from distant monitoring networks, seismum, heaters hundreds or thousands of kilometers away, combined with satellite passes when conditions allow. The 2021 earthquake demonstrated exactly what that distance costs you in situational awareness. It produced a tsunami that crossed 3 oceans, and the earthquake that generated it wasn't correctly identified until after the fact. In practical terms, this is one of the least monitored active subduction zones on the planet, precisely because of how hostile and remote it is. This matters beyond the immediate area because of what a major rupture here can do to ocean basins thousands of kilometers away. The 2021 tsunami was recorded across the South Atlantic and into the Indian Ocean. The waves themselves were relatively modest. The largest coastal amplitude measured was rough, a 75 centimeters at South Georgia Island, about 800 kilometers from the epicenter. But research on the 2021 event found that the oceanic ridge systems in the South Atlantic act as waveguides, channeling tsunami energy in directions that basic propagation models didn't fully predict. The wave was recorded at stations FA, far beyond what simple models suggested it should reach. If a significantly larger rupture occurred in the same zone, and the geological evidence says it can, the resulting wave's behavior would need to be modeled against the same uncertainties the 2021 event exposed, uncertainties that, by definition, we don't yet fully understand. The historical record backs this up. The largest earthquake prior to 2021 in this region was a magnitude 8.3 event on June 27, 1929, along the northern section of the arc. Hydrodynamic simulations of that event suggest it generated P water tsunami amplitudes reaching 30 centimeters off the coast of Brazil and 20 centimeters along the Gulf of Guinea in West Africa, thousands of kilometers from the source. Whether those waves were actually observed and recorded in 1929 is uncertain, partly because Kiowa-style monitoring infrastructure in the South Atlantic was sparse at the time. But the modeled propagation behavior, combined with what 2021 actually demonstrated in real recorded data, establishes that this subduction zone is a legitimate source of South Atlantic tsunami. I hazard at intercontinental distances. It isn't the Pacific Ring of Fire, which carries the highest global tsunami hazard profile on Earth, but it isn't negligible, and its remote location has historically kept it well outside the attention it scientifically warrants. The plate architecture here is also unusual in a way that makes the dynamics particularly complex. The South Sandwich microplate is a small young piece of oceanic crust, bounded not just by the subducting South American plate to the east, but by the Antarctic plate to the south, and the Scotia plate to the west. To the west of the volcanic arc, a mid-ocean spreading ridge called the East Scotia Ridge is actively creating new ocean floor, pushing the Sandwich plate eastward, even as its eastern margin is simultaneously being consumed by subduction. The plate is growing on one side and shrinking on the other at the same time, producing an internal stress environment that feeds both the subduction zone earthquakes and the volcanic arc sitting above it. The subducting South American slab extends all the way to Darwin to roughly 850 kilometers depth before dissipating into the mantle, making this one of the deeper slab systems in the global record. At those depths, mineral phase transitions in the descending rock can themselves trigger what seismologists call deep focus earthquakes, events far below the normal seismic zone that can transmit energy upward through the entire column of the Earth in ways that are difficult to predict from surface observations alone. The magnitude 6.0 on August 12, 2026, at 10 kilometers depth, sits in the upper brittle portion of the subducting slab, or the overriding plate, where elastic energy accumulates along the fault interface and releases as rock fractures. It's the kind of event this zone produces routinely. The South Sandwich Trench generates earthquakes constantly. Most are small, some aren't. A magnitude 6.4 appeared in USGS records at the same zone just weeks ago. Before this one. Before that, the 2021 magnitude 8.1. Before that, the 1929 magnitude 8.3. This zone has a documented history of punctuating long stretches of moderate seismicity with significantly larger ruptures, and the 2021 sequence showed that the jump from moderate background activity to a major rupture can happen with almost no additional warning. The 7.5 foreshock preceded the 8.1 main shock by 3 minutes. 3 minutes is not a warning, it's a postscript. What this means for right now is not that another large earthquake is imminent. Nobody can say that, and responsible science doesn't say it. What it means is that this zone is active, documented, and capable, and that the August 12th magnitude 6.0 is a reminder that the machinery running beneath that remote ocean is not idle. It's working. Plate after plate, kilometer after kilometer of ocean floor sliding into the earth beneath the South Sandwich Islands. The volcanic arc is fed by it. The lava lake on Mount Michael exists because of it. The earthquake's USGS plots on its map are the sound of it, and the rate Mo search on the 2021 sequence established in peer-reviewed literature that the potential maximum magnitude for a rupture in this zone could approach 9.0. That number hasn't been reached in the instrumental record. The 1929 and 2021 events both approached or reached 8.1 to 8.3. Whether the locked sections of the interface can accumulate enough stress to eventually produce something larger remains a genuinely open scientific question. Here's the piece of context that should stay with you. The South Sandwich Islands being completely uninhabited means an earthquake and tsunami sequence there causes no direct casualties from shaking. But the relevant population for tsunami hazard isn't on the islands. It's on the coastlines of South America, West Africa, and potentially beyond. The 2021 event decays over time following roughly an inverse. The numbers explain why here it's doing so along a fault patches are, and how much strain is already in another section further north. Now, where does that leave the August 12th, one of which currently maintains a persistence to 3 oceans? The physical constraints of the answer to what comes next from the South Sandwich Islands is the same sequence was the one nobody saw until it was already over.